Hi, and welcome to Integrated Science. Today we are going to be discussing how to use motion maps by using a simulation through PHET, Colorado, with the Moving Man simulation. So in Canvas, you'll see that there is an assignment called Moving Man, PHET, and go through and I kind of just talk a little bit about the idea that we are going to be looking at graphs today of a position graph, a velocity graph, and acceleration graph. Clearly, we've only talked about position with scalar and vector models. However, we're going to be moving into velocity and acceleration. So we're going to go ahead and kind of introduce them today. So you're going to go ahead and click in here, and I've already got it open for you, which is our CAMI document that's going to allow us to write all over this and fix our charts and write an explanation for them. So first off, to get started, you need to Google PHET, Moving Man Simulation. And so once you do that, and let me go back just a little bit so you can see it too. So I'm at Google, and if you just type in PHET, Moving Man, you can see lots of people have used it. You're gonna click in there and it's gonna pull this up. All you need to do is click play or hit the play button and it's gonna pull up the simulation for you. This is compatible with your Chromebook. So if you're getting an error message, maybe log out of everything and then move back in. It is something that will allow you to go through the system and use it on your Chromebook. So two different types of tabs here, introduction and charts. We're actually going to be working on the charts tab today. And let's go back to CAMI just to take a look at the actual directions. So it says switch to the chart tab, which we just did, at the top of the simulation, then play with the Moving Man simulation for approximately 5 minutes. Try changing the position, velocity, and acceleration values by using the sliders and by typing in numbers. Familiarize yourself with the recording or playback features. While you do this, look at the graphs and make sure you understand what is happening. So a couple of different things is, once again, as you can see, that this gives you the actual and kind of move it around, but so you can position them here however you want. Let's say I'm going to take them to the right here, the brick wall, and I want him to move at a rate of 4. Let's see if I can get it like to more of an even number, 4.5. And let's make the acceleration 2. So this is nice. You can see it. We have our velocity vectors. Oh, look at that. It's giving our arrow with our direction. So there we go. We've got our qualitative data and we have quantitative data. So two big things we're going to be looking at. And if you flip over to the charts, you can see it doesn't work in there. So make sure when you're doing this today, so you can run it just so that you can see him moving through. And whoop, do that brick wall. And I'm going to stop it there so we have a good time. So if we go to the charts, it doesn't record. So we want to make sure that you are kind of setting them up to move here. So I like using just typing in the numbers, but you can clearly move him here too to kind of help with that. So let's say that we want him to start at this brick wall again. And we had the velocity. Oops. There we go. Reset. I lied. Set your positions in there. So let's say that I want him at -10 and I want the velocity to be 5 meters per second and I want him to accelerate every 2 meters per second. Now these two terms probably don't make a whole lot of sense to you right now. I promise by the end of a week or two you will be able to be like, oh, I totally know what that means. But these are just different speeds. Velocity is speed with direction, so we're sending them with our vector. So watch the way the arrows go. And then finally, acceleration is the velocity of how fast an object is going between a certain amount of time. So think about like speeding up and slowing down. Our acceleration is that you can accelerate forward at a faster rate. You can start off slow. Like if you're at a red light and the light turns green, you go from 0 to maybe 35 miles per hour. That's an acceleration. Or if you're at 35 miles per hour and you go down to 0, that's an acceleration too. And we'll talk more about that later. But for right now, we're going to mostly focus in on this position one because that's where we kind of worked on yesterday. So if you hit play, you can see that we get a couple of different things. So I'm going to hit stop right here. He's kind of almost in the middle. Actually, let him go for a little bit further. Get him to the house. There we go. All right, so he's at the house here. So what we're looking at is a couple of different things. Is that we can see his position has changed from -10 to almost about 9 meters. So we can see that the 0 meters here. We can go backwards and forwards. We could change his direction if we wanted to, and then make him go back. And you can see that he's going back down. Let's get him back to where he started there. And start the time there. So we can see that his position went, and then he stopped here for a little bit and then went back to his -10 position. We can look at the velocity and see that he was kind of moving at a constant velocity when I had him stop at the house about here at the 8 or 9 meter marker. Then I had him kind of turn back around and go back, so then the line got really swiggly there. And then acceleration too, it was a little bit more constant, and then I kind of pulled him back with my cursor. So changed it just a little bit. So we're going to focus in on these 3 charts. So I'm going to go ahead and reset this one here. And let's jump back to our Cami doc and look at what we're asked to do. So it's asking, draw what the graphs look like for the following situation. You do not need to put numbers in the graph at this point. We're only concerned about the shapes of the graphs. So as you can see, there's a couple different scenarios. We are going to work on the first one here, which says the man starts at the tree and moves towards the house with a constant velocity. Stop the man when he gets to the house. Set position to -8 and the velocity to 2 meters. So let's jump back here. We're going to set our position to -8, and we're going to set our position at 2 meters. And as you can see, we are now going to leave acceleration at 0. And so now let's run it. Let's just run through the whole process here and see what happens. I do believe they asked us to stop him at the house. Yep, stop him at the house. Hopefully I'm not there yet. Moving a little bit slower. And we'll wait until he gets to the door. There we go. All right, so now we have 3 different maps that we're going to be looking at here. So he's changed his position from the -8 to 7.75. -8 right about here to about 7.5, so we can see that he's moved up. His velocity was constant. He moved at a constant speed. So think about maybe him being on like a conveyor belt that's moving at a constant, and he wasn't accelerating because he was at constant. So let's jump back to Cami. And so they want us to draw what it looks like here. So I'm going to pick the drawing paintbrush. I'm going to pick pink as my color and kind of a lighter number here. So not worried about the numbers, but if you want to kind of just think about this, this is our 0 here. 0 for all of them. My handwriting on the computer is amazing. And then this would be -10. +10, -10, positive, negative, positive. So this one here, think about it. We started him at -8, so not completely at the bottom, but pretty close. And then we stopped him almost at that 8 or 7.75. So our first line kind of looked like this. So I'll go back and see. Close enough. So pretty close. So then we're going to answer the question that goes along with it, is why does the graph start at 0? And the graph starts at 0 because starts below 0, sorry. He starts at below 0 because we position him there. Man started position at -8, and that's it. That's all. Whoops, can't spell. You guys know that by now. All right, so man started position at -8. So we started him here and then moved up this way. The velocity of our graph. Let's go back and take a look at that, which is going to be constant. So remember, it's not at 0, it's a little bit above. So we are going to draw our line just slightly above there too. So back to our paintbrush and freehand this just a little bit. And as you can see, I wobbled, which is okay. And let's type in now what they're asking. So if the man is moving, why is the line flat? the line is flat because he was a constant. It was a constant speed. So the man was moving at a constant speed. Let's even be more detailed. Speed of 2 meters per second. So quantitative information, qualitative information. Then I've even added some more quantitative information. So then acceleration, there was no acceleration. It was at 0. So if you think about what we're looking at here, it was completely at 0. So we're going to go back here and do the same thing. Draw our line in almost right there on that 0 marker. And then we're going to go to our text box. And the question now asks, why is the acceleration at 0? And that is because the moving man was moving at a constant velocity. And so he didn't change his speed or anything like that. So that kind of changes it there too. So what you're going to do now is go through the other scenarios, set up the graph appropriately. As you can see, there's quite a few of them. And then answer those questions that go along with it. And the last one's kind of fun because you get to test it yourself. And then finally at the end, you have some questions to answer. So hopefully this was helpful. These are simulations we'll use quite a bit. So if you have questions, please ask.